So in this video I'm going to wrap up lesson 8.4 with a couple of pieces that we need to make sure we cover. The first part is how to rewrite an equation for a different variable, because sometimes in geometry we've seen these formulas in physics or in chemistry. You'll see different formulas, and sometimes the way it's set up is not the most beneficial to you. Like maybe in this first example where we need to find the volume of a cylinder, right now it's solved for V, but maybe it'd be more beneficial for the problems that we'd be working on to have it solved for R. And that would be it'd be beneficial if I knew the value for V and if I knew a value for H. If I wanted to plug it in here, it'd be a lot easier if I had it solved for R. So that's what I'm going to do here. So to start off with, the way that we're going to approach these problems is we're going to do the opposite of the order of operations. So my first step is to get the R by itself by dividing both sides by pi and h. In other words, we save the exponent for the end. So if I divide both sides by pi and h, the pi's cancel out, the h's cancel out, leaving me with r squared equals v divided by pi times h. Now we have the r by itself, but I still have an r squared in there. So I want to get rid of the square. So the only thing that gets rid of a square, the only thing that undoes a square, is the square root. So the square root would undo the square, leaving me with r equals the square root of v divided by pi times h. And that's my answer. I'm not going to do anything more with that. That's my final answer. Now sometimes you'll see equations that have a fraction in it, like this one here. It's no good if you have a fraction. We want to get rid of that fraction. So before I do anything else, before I get rid of the pi or the h, or do anything with those, I want to get rid of the fraction. So we learned about this in chapter 1, but to get rid of a fraction, what we're going to do is we're going to multiply both sides by the common denominator. Now there's only one denominator here, so it makes it even that much more easier. So I'm going to multiply both sides by my denominator, which is 3. Now 3 times v gives me 3v. Now I'm multiplying this whole thing by 3. So let's kind of go off to the side over here for a second. You don't have to write this down. But if I had a problem like this, if I had 3 times 2x, you know your answer would be 6x. You wouldn't even think twice about it. It makes sense. 3 times 2x's would be 6x's. Well, here, this is one term. You wouldn't think that, oh, I have to take 3 times 2 and 3 times x. You know, that's just 3 times 2 is 6x. The same thing's true as here. This is all one term. We're not going to take 3 times the 1/3 and 3 times pi and 3 times r squared and 3 times h, because since it's all one term, I only have to multiply it times that one term just once. So 3 times 1/3 is 1, leaving me with just 1 pi or pi r squared h. So you don't have to multiply the pi, the r, or the h by 3, because we've already multiplied this term by 3. Now my goal is to get the r by itself. So I'm going to divide both sides by pi and h, giving me my r squared equals 3v divided by pi and h. Again, the only thing that undoes a square is taking a square root. So I take the square root of both sides, leaving me with r equals the square root of 3v divided by pi times h. And that's my answer. I'm not going to do anything more with that. So that's how we rewrite equations for a different variable. The next thing I'm going to talk about is the geometric mean. Now you want to make sure that you get this definition for the geometric mean down in your notes, but I want to review first what the arithmetic mean, or the average, is here. An average, that's what you're familiar with. Again, that's the same as the arithmetic mean. That's where you add up the numbers and divide by how many there are. So examples of where you see the arithmetic mean is or your average, you'd be looking at your test scores. If you find the average, you'd add them all up and divide by how many there are. If you wanted to figure out the average height in the classroom, you would add up all the people's heights and divide by how many people there were. But the problem with that is you sometimes see examples like the one in purple here, where we have a number like 525 that's way off from the rest of the crowd. Or you call that an outlier. Well, in a situation like that, that's where we want to use the geometric mean. Here's how we find the geometric mean. You multiply together all the numbers in a set and then take the nth root for the amount of numbers that were in the set. In other words, here I have a total of 7 numbers. To find the geometric mean, I'm going to multiply these 7 numbers together and then take the 7th root of the product. Now, again, we use this when one of the numbers may give an inaccurate measure of center, because that's what the average or the mean is doing. It's finding a measure of center, where approximately is the middle. Now, I'm going to give you this one. If you're to add up all these numbers, the arithmetic mean for this set, or the average for this set would be 145.4. Now, if you notice, that's not a very good measure of center, because 145.4, I have two numbers that are more than 145.4, and I have 1, 2, 3, 4, 5 numbers that are less than that. So it's a really inaccurate, it's a skewed measure of center there. So we want a better measure of center, so we're going to find the geometric mean. So to do that, we're going to take, there's 7 numbers, so we're going to take the 7th root of 25 times 122 times 16 times 200 times 50 times 80 times 525. So why don't you get out your calculator, and I'll show you how to do this on your calculator. So we're going to go to a calculator screen. So what you're going to do is you're going to look for your nth root button, which is over here above the caret button. Now, if you have a TI Inspire calculator, it makes it a lot easier, because when you do this, notice how we have 2 text boxes. So we can see right away that this first text box is for the root. The second text box is where we're going to type in all the numbers we're going to multiply together. So there's 7 numbers that we're multiplying together, so I'm going to take the 7th root. We arrow over to get to the under the root here, and here's where we're going to type in all those numbers we're multiplying together. So 25 times 122 times 16 times 200 times 50 times 80. When I do that, oops, I forgot the most important one, my bad, times 525. So our geometric mean is the second number here, that's the right one, is 79.7, or we can round it up to 80 is your answer. So 79.7 or 80. So you notice that these two this is almost, the arithmetic mean is almost twice as much as your geometric mean. So you can see that the arithmetic mean would be a very poor measure of center. And this is why a lot of times newspapers or politicians and other people, sometimes they can use data and they can manipulate it to persuade people for their opinion. Because you can see both of these are measures of center, both of these are averages, but the geometric mean is a more accurate average here. Because if you notice 80, if we rounded that to 80, well, we have one number that's exactly 80, and then we would have 1, 2, 3 numbers that are less than 80, and I have 1, 2, 3 numbers that are more than 80. So it just so happened to turn out in this case that our geometric mean and the median are the same value. So that's a good measure of center there. So that's the geometric mean. So I'm going to stop this video now. Your next assignment, actually the first part covers lesson 8.4. The second part of your next assignment is going to cover 8.5. So to do your next assignment, you're going to want to make sure that you watch the next video as well. So with that, good luck on that, at least the 8.4 part of your assignment.